Hello, everyone. Yeah, I will try to tell you a little bit more than only about the quantum dots for UV light conversion. First of all, I would like to introduce you shortly our company. We are a company located in Poland. We focusing on producing, developing new nanomaterials, inorganic nanomaterials, and on the modification of these materials to different kinds of applications. We are 25 people right now, located in Technological Park in Wrocław, where we are also doing production, not only development, but also going to produce materials in-house. We, as mentioned, building and developing infrastructure for synthesizing, for producing nanomaterials. We develop materials themselves. We do surface modification. And for those customers who decide to print nanomaterials, we also develop different kinds of inks. Our focus for now are semiconducting quantum dots. Most of you are familiar with this material. It's just a semiconducting small crystal, 10, 20 nanometers inside, where the core is responsible for the quality of the material, the shell simplifying stuff is responsible for stability of the material, and the organic ligands on the top are responsible for compatibility of this material with the host, or more generally with the device. We decided to focus some years ago on blue light emitting quantum dots, which are heavy metal free. And for now, we have two kinds of products, the deep blue light quantum dots emitting from roughly 420 up to 440, 45, and the other group of materials emitting from 445 up to 460, 70 nanometers. So in parallel to material development, we were developing also infrastructure for producing materials. So this year, we launched our first pilot production line. So once the material is working, it's optimized for your products, we are able to deliver material to satisfy your expectation regarding the testing, prototyping, or even pilot production. So we are ready also for further scaling already. So a few words about our products, and then I will just discuss a bit about the possible application of our materials. So we deliver the quantum dots, which has quite high quality, optical quality, so quantum efficiency could be higher than 90% for some wavelengths. The color quality is also very high. As I mentioned, we can tune the emission wavelength as you want, so we can customize the material. And I think the most important here is also that we can deliver material in different solvents and also in different monomers if you would like to do something else with this material on your side. And I mentioned before, we can deliver this material even in a kilogram scale if it's needed. Here you can see a few specs regarding the deep blue and pure blue materials. So for deep blue, you can go down even to 11 nanometers with the broadening, which is really sharp. For pure blue materials, more interesting for display industry, typically it's around 25 nanometers, but for some wavelengths, we can also achieve around 20 nanometers optical quality. We develop these materials toward two kinds of application. The first one, and to be honest, the core application for us is our electroluminescence displays, so QDEL displays. And the second group of application for our materials are application which use the light conversion, including AR glasses, smartwatches, but also optical communication. And I would try to give you a few data for both types of applications. So for electroluminescence excitation, quantum dots, the idea is to change electricity to light. In this case, you have to put material between a stack of other materials. So in principle, you replaced low-quality organic emitters in OLED architecture by quantum dots, and you get much better quality of devices. On the other hand, for photoluminescence application, you need only the light source, in this case, the UV light, to excite material and to convert UV light to blue light. We also work on the UV curable inks for this PL application. And right now, we also have reasonably good PL quantum yield for the layer. For some wavelengths, close to 90%. The stability is also not bad. We're still working on that, especially for higher fluxes. We're testing new compositions. And I think this is what I would like to show at this point. For AR application, we are working on photoresist because with the UV ink, it's really hard to go for small pixels. But photoresist is much easier, so we spend a lot of time right now on developing photoresist, which based on our quantum dots.